This is the fur, this is the Teflon rod. So before I rub them, and I put the rod close to the fur. So now I can hear some sound. Next time I'm going to check the sign of the charge. When I rub the Teflon rod with the fur is positively charged and this rod is negatively charged. So if I put it close to the electroscope, look at there. Now there is induced charge on the electroscope. Now I'm going to touch them so that the electroscope is going to be positively charged. When I remove the rod, this electroscope is now positively charged. Now I have two straws with tape, identical. I'm going to put them close and see what happens. Oh, look at that. Now, can you tell me, do they carry the same charge or unlike charge? Now I'm going to press this one against the desk. Next time I'm going to put them close. Whoa, look at that. They attract now. Can you tell me what happened when you press the tape against the desk? Next, I want to find out what type of charge on the tape, positive or negative. I know this rod, after I rub with the fur, this is the negatively charged. Looks like they repel. Can you tell me what type of charge does the tape carry? Next, I'm going to put this flag close to the fur. not very obvious, probably not enough charge. Let's put the tape close to the fur. Can you see what happened to the fur? Do they attract or do they repel? Does that mean what type of charge is carried by this tape? Now this can now is at rest. I know it's metal. Let's look at what happened to the can. I'm going to put this rod close to the... Oh, look at that. Do they attract or do they repel? What type of charge is... So as long as there is no touch, this can is not charged. Can you see what happened? Some of them jump away. Some of them stick on the bottom. So the second part, if you place this one in bright light, we're supposed to observe some dust, but it's very hard to see the dust, especially through the camera. I will skip that. But now I just noticed, look at this carp. This carp is charged. Look at the fur of the carp. They stand up. Can you see them? Can you explain why do they stand up like that? Activity 4, I'm going to study these two carps. First, I'm going to rub one of the carp a lot. And the second one, just a little bit. Failed, didn't Cool, now they repel. They are not clean to each other. Next, I'm going to measure the angle. So the angle deflection from the vertical line, that's the 90 degree. This is about 12 degree. So left side is about maybe 78, right side 102. So I will say my theta now is equal to around 10 or 12. Now it's 10. I think that there are less charge now. Next, I'm going to measure L. L is from the middle of the line to the center of this carp. I'm going to measure the total length. That will be 2L, from the left center of the carp to the right center of the carp. So this side 0, 0 match the center. This side is about 80 centimeter. Therefore, my L is half of that. Now I have L equal to 40 centimeter, theta equal to 10 degree. So this part is about conductors, insulators, and electroscope. So on this desk we have a fur, we have plastic rod, we have some cloth, and we have this protractor, we have this ruler. They are all insulator. That means the charge cannot move from one position to another position. They can move a little bit here, but they can move a large distance. And I have electroscope. Electroscope is made of several pieces of metal. Metals are very good conductor. That means the electron can move from this position all the way to the bottom. And this is metal, this is also metal, this is also metal, because they feel cold. And at the bottom, This is the plastic. So plastic is a good insulator. You don't want, because we want to test the charge of this electroscope. So you don't want the charge to go away. You want the charge to stay inside. So this bottom is good insulators. Initially, this electroscope now is neutral. That means equal amount of positive and negative charge because the needle is not rotating. Next, I have a Teflon rod. I just rub it with the fur. Next, I'm going to put it close to the rod. Look at what happened to the needle. The needle rotate away. That means it's repelled from the vertical. That means they carry the same charge here. Now, if I put it close, it's repelled. But if I remove it, it go back to normal. So that means there is still no charge on this electroscope. But when I put this one close here, their electron are, this rod is negatively charged. And the electron from the metal, they are repelled from the rod all the way to the bottom. And the vertical and this needle, they carry the same negative charge. That's why they repel. But if I remove the rod, they go back to normal because the whole thing, they are neutral. But how about if I touch it? Now, if I touch it, I do it like this because this rod is insulated. The charge does not move very well. You need to rub it so that something will happen between the rod and the metal. Now, you see there are more charge on this electroscope. Next, I'm going to remove the rod. Do you think the needle will go back to normal? No, maybe a little bit. That means now this rod is charged by rubbing this rod with the ball, and this electroscope now is charged, and it must be the same charge as this rod because this is negatively charged. Electron jump from this rod to the electroscope. Now it stays there. Next, I'm going to use the electroscope to test the sign of the charge carried by this rod. So I rubbed this rod with this cloth. I'm not sure is it positive or negatively charged. Now, if I bring it close to the electroscope, look at the needle. What happened to the needle? It repelled more. The angle is greater. That means this rod and this ball carry the same type of charge. They are repelling a lot. So there are more and more electrons are moving to this side. Next, I'm going to finish activity 5 by touching the rod. Can you so my body, I'm a conductor or insulator. So look at what happened. Whoa, back to vertical. Now this rod is not charged anymore. This is the part of activity 6. So I have tap water running, and I have Teflon rod and rubbed with fur. And next I'm going to bring this rod close to the water. Look at that. Water is attracted by this rod. Is this tap water a conductor or insulator? So when I bring this rod close to the electroscope, there is a separation of positive and negative charge. It's called the polarization. Electrons are repelled from the electron inside the metal, inside the electroscope, are repelled from the rod, move to all the way to the bottom of this electroscope, and some of them are the other side of the ball. So when I touch the other hand, so the electron will jump from the rod to my hand. Next, if I remove my hand, remove the rod, you see this electroscope is charged and positively charged, and it's opposite the sign of the charge carried by this rod.